Hello students, I am Dr. Shivangi Bissa, Assistant Professor, Department of Physics, Engineering College, Bikaner. As you all know that our nation is suffering from the COVID-19 trauma and we are all forced to stay at home, and during this lockdown period many of our students are lacking in their studies. So to make use of this period, I am preparing some e-lectures which definitely will be beneficial for them and would help them to continue their studies. So, the topic which we are going to study today is about interference of light. So, starting with the definition of interference, we know that interference is the phenomena in which two light waves having nearly equal frequency and equal amplitude superimpose each other under a very important condition. What is that condition? That condition is the phase difference between them should be constant with respect to time. यानी कि स्टूडेंट्स, व्यतिकरण क्या होता है? व्यतिकरण से आप क्या समझते हो, यही हम इस यूनिट में देखेंगे। व्यतिकरण का मीनिंग है जब कोई दो तरंगें जिनकी आवृत्ति और आयाम लगभग समान होते हैं आपस में एक ही दिशा में चलती हुई शून्य कलांतर के द्वारा अध्यारोपित होती हैं, तो उस घटना में हमें डार्क और ब्राइट फ्रिंजेस प्राप्त होती हैं. So we get bright and dark fringes during this phenomena, and this whole experiment, this whole phenomena is called interference. The basic requirement of this interference phenomena to take place is that the phase difference between the waves should be constant. Means the sources which we are using should be coherent, यानी कि कला सम्बद्ध होने चाहिए. Now, what are coherent sources? So, coherent sources are the sources which emit light waves having same frequency and constant phase difference. There are basically two methods to produce such kind of sources. One is by division of wavefront and one is the division of amplitude. In the division of wavefront method, what we do is we divide the wavefronts obtained by a single wave into two wavefronts by passing the lights coming from the single source through two slits placed in front of it, like the Young's double slit experiment. The other method to produce the coherent sources is by the division of amplitude. In this method, what we do? We divide the amplitude of a single wave coming from the source into two amplitudes, either by reflecting the wave through a lens or half silvered glass plate or a mirror. In this way, when a half silver glass plate is placed in front of these waves, they are partially reflected and partially refracted. As a result, the single amplitude is divided into two different amplitudes, and the two different waves obtained are coherent in nature. This type of method is used in the Michelson interferometer experiment. Examples of coherent sources are laser. As we all know that laser light is the highly coherent source as it functions on the phenomena of stimulated emission of radiation. It is a phenomena in which an atom which is in excited state drops down to the ground state under the influence of an incoming photon with the release of two additional photons of same energy. As a result, the waves obtained in the output have equal energy, and we say that they are coherent in nature. Sound waves are the other example of coherent sources. That is, the electrical signals from the sound waves travel with the same frequency and phase. So students, as an example of coherent source, the best example is of the laser light, and the other example is of the sound waves. Now coming again to the interference. Interference can either be constructive and it can be destructive in nature. Now, as you all know, due to the interference phenomena, we get bright and dark fringes. Why do these fringes form? When do we get the dark fringe and when do we get the bright fringe? To explain this, we have to consider the intensity distribution of the waves when they are superimposed on the screen after passing to the coherent sources. When the crest of one wave fall on the crest of another wave, then we find the resultant amplitude is maximum. Thus, in this case, we get a bright fringe and we say that it is a constructive kind of interference. Another equation which describes the constructive interference is about the path difference. Friends, what is a path difference? So, path difference is the difference of the path traveled by the two waves which are superposing with each other. The phase difference can be calculated by this path difference as it is 2 pi by lambda of this path difference. Now, coming to the main equation regarding the constructive interference, then for constructive interference, the path difference between the waves which are superimposing with each other should be equal to the n multiple of lambda. Means delta, if delta represents the path difference, then delta should be equal to n lambda, where n equals to 1, 2, 3, dash, 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 any integer. Similarly, destructive interference takes place when the crest of one wave falls on the trough of another wave, and in this case the resultant amplitude is minimum. The condition for destructive interference is that the path difference should be odd integral multiple of lambda by 2. When destructive interference takes place between the waves, then as a result we get dark fringes. Now the first experiment, as I told you earlier, was the Young's double slit experiment, which was first performed to observe the interference phenomena. In this experiment, as shown in the figure, light coming from a single source S1 is passed through two slits made on a hardboard S2, which is B and C, and we can see that the single wavefront coming from the slit A, when passed through B and C, divides into two wavefronts, and these wavefronts superimpose each other at the screen F, giving us bright and dark bands which are called the fringes. This is the interference pattern which was first observed by Young in the Young's double slit experiment. One point we should note here that the waves obtained after passing through slits B and C becomes coherent in nature, and as a result of their superposition, interference takes place. Now, what are the conditions for sustained interference? As I discussed before, the main requirement of interference is that the sources should be coherent in nature. Means the source should be such that the waves obtained from them have a zero phase difference or a constant phase difference with respect to time. The second important requirement is that the amplitudes and intensities of the waves interfering with each other must be almost same. The third important requirement is the main source should be a point source of light. The fourth requirement is the interfering source must be near enough to produce the wide fringes. From this condition, we mean that when a single wavefront is passed through the two slits, then the two slits should not be far enough. They must be at a proper distance so that the secondary wavefronts obtained from them can be interfered properly and produce a good contrast interference fringes on the screen. The source and screen must be far enough to produce the wide fringes. This means there should be a proper distance kept between the source and screen so that a clear visible pattern of fringes is obtained on the screen. The sources must emit light in same state of polarization. In this case, if we are using polarized light, then the state of polarization of both the interfering waves should be same. And the last requirement is the source should be monochromatic. Means a single wavelength source should be used to observe the interference phenomena. Now, coming towards the thin film interference, first of all, I would let you know some of the examples about the thin film interference. Thin film interference is mainly observed in our daily routine life as we see colors in the soap bubble, colors in the layer of a soap oil. These are some of the examples of thin film interference.